What's the closest thing to being a wizard in the real world? And that's like creating new technologies.
There's some radical technology prediction. The point is not that it was a few years late, but that it happened at all.
In a world where mobility defines participation, the limitations of traditional wheelchairs remain a quiet yet profound barrier for millions. According to the World Health Organization, around 80 million people globally rely on wheelchairs to navigate daily life, yet many are constrained by designs that have seen only incremental improvements for decades. The range remains limited, control can be tedious, and terrain challenges or crowded environments often render movement clumsy or risky. What if that paradigm could be disrupted, not by incremental updates, but by a radical leap in autonomy, intelligence, and integration? Imagine a wheelchair that thinks, navigates, and adapts on its own. Essentially, a personal mobility robot. In this speculative narrative, we explore the possibility that Tesla, a company synonymous with redefining transportation and automation, might be quietly developing a 2025 Tesla wheelchair, a self-driving AI-powered wheelchair that could reshape how people with disabilities move through the world. Let me emphasize up front, this is speculative. Tesla has made no official announcements about such a product. There is no press release, no patent explicitly stating wheelchair, and no confirmed roadmap. Rather, this is an educated, imaginative projection based on Tesla's known strengths in autonomy, robotics, artificial intelligence, and embedded systems. The goal here is to paint a vision, one that, if even partly realized, would constitute a genuine game changer in assistive mobility. If you're curious about disruptive ideas like this, I invite you to subscribe. I'd love to count you among subscriber number 16,189 as we track developments together. Just as Tesla once transformed perceptions of personal transportation, this Tesla wheelchair could perform what feels like technological magic, navigating complex indoor and outdoor environments, avoiding obstacles in real time, understanding voice commands, integrating with apps and ecosystems, and doing so at a price point that makes it far more accessible than current high-end alternatives. This imagined device sits at the intersection of assistive tech, robotics, and mass mobility, with the potential to change not just how one moves, but how one lives. Let us now dig into the speculative features that would make such a product compelling, and in many ways, revolutionary. First, consider the heart of autonomy and intelligence. Taking a page from Tesla's full self-driving FSD system for automobiles, the 2025 Tesla wheelchair would ideally include a miniature yet powerful onboard autonomy stack, cameras, LiDAR, or solid-state depth sensors, ultrasonic sensors, and radar modules could provide 360-degree awareness of the environment. The embedded AI would process sensor input to plan safe trajectories, avoid collisions, and navigate through dynamic terrain, shifting crowds, tight corridors, uneven surfaces, doorways, curbs, ramps, or even elevators. The wheelchair might accept destination commands, go to kitchen, go to living room, and physically transport itself there, without manual joystick input. Voice recognition or natural language instructions could allow hands-free direction, a capability especially meaningful for users with limited upper body mobility. Paired with that, an integrated smartphone or Tesla app could connect wirelessly to the wheelchair. From that app, users or caregivers might configure routes, check battery level, schedule maintenance, or even perform diagnostics remotely. The embedded AI could monitor internal components over time and issue proactive alerts for motor wear, battery degradation, sensor calibration, to prevent breakdowns before they happen. Tesla's experience in over-the-air OTA updates would allow continuous improvement. New navigation features, enhanced adaptive software, or bug fixes could be delivered just like with its cars. When it comes to speed and agility, this wheelchair would aim to exceed traditional limits. While many current electric wheelchairs top out at 48 miles per hour, mph, our imagined 2025 Tesla wheelchair might achieve 8 to 12 mph, making it suitable not just for indoor or campus use, but for urban corridors, sidewalks, or large campus complexes. Combined with advanced pivoting wheels or omnidirectional drive, it could rotate in tight spaces and maneuver elegantly through interiors or crowded environments. The turning radius could shrink via clever mechanical design, enabling it to navigate hallways, elevators, or intermediate thresholds with ease. Material choice would play a crucial role. To stay lightweight yet durable, imagine a frame incorporating carbon fiber composites or advanced aluminum alloys, keeping mass between 50 and 75 pounds, versus 100-200 lb for many current models. A lighter wheelchair ensures easier transport, loading into vehicles, carrying up ramps, or collapsing for travel. Despite its advanced electronics and motors, efficient design and modular components would help keep weight manageable without sacrificing robustness. Energy storage and range form another key axis. Borrowing from Tesla's battery expertise, the wheelchair might house a compact but high-energy density lithium-ion battery pack. I imagine a realistic range of 40 to 60 miles on a single charge, roughly double or triple the 10-20 mile range of conventional electric wheelchairs. And in true Tesla fashion, it could be compatible with fast-charging infrastructure or even a pared-down supercharger standard, allowing quick top-ups during breaks or between appointments. Charging routines might be intelligent and adaptive, e.g. charge scheduling, battery conditioning, and the system might prioritize battery longevity with thermal management, cell balancing, and predictive battery health algorithms. Next, let's compare this speculative design with existing wheelchair models too, and highlight where Tesla's vision might truly shine. Traditional electric wheelchairs often have shortcomings that hamper flexibility. They tend to be heavy, 100-200 lb, limiting portability. Their ranges are usually in the 10 to 20 mile bracket, and control typically falls to a joystick interface, which can be fatiguing or impossible for users with limited dexterity. Some higher-end adaptations allow sip and puff or head-mounted controls, but they often lack autonomy or intelligent navigation. Now consider some of the premium models already on the market. Permobil is a leader known for its comfortable, adjustable seating systems, tilt, recline, elevating footrests that enhance usability and reduce the risk of pressure ulcers. Yet Permobil units still rely on manual control inputs, joystick, or alternative interfaces. They do not autonomously navigate environments or avoid obstacles. Will produces compact, elegantly designed indoor-outdoor power chairs with smooth suspension, agile wheels, and stylish aesthetics. Their designs excel in maneuverability and comfort, but they remain fundamentally reactive. The user commands direction, and the wheelchair complies. They do not incorporate deep AI autonomy or full predictive path planning at present. Against both of these, the Tesla wheelchair would potentially deliver an entirely different experience. A device that understands where you want to go, navigates there intelligently, with minimal human input beyond high-level direction. In other words, it steps into the realm of an autonomous transport companion rather than just a motorized seat. Imagine waking and telling your wheelchair, "Take me downstairs," and having it prompt the elevator, move, wait, sense door thresholds, and arrive without your hands ever touching a joystick. So you might wonder, would I be excited about the Tesla wheelchair if it existed? If you believe in innovation and autonomy, the thought alone might spark anticipation. Let me know what you think. What features would matter most to you? Now let's turn to what is known, or speculated, about its public disclosure timeline and availability. Thus far, Tesla has made no formal announcement regarding a wheelchair product. None of its quarterly earnings calls mention assistive mobility, and no patent explicitly references wheelchair. That said, interesting whispers and signals exist in hobbyist communities and social channels. One frequently cited piece of speculation involves a design engineer named Massimo, followed by Elon Musk on X, formerly Twitter. Some of Massimo's posts have shown conceptual sketches that resemble compact mobility platforms, though nothing conclusive. These remain circumstantial and speculative, rather than definitive. Given Tesla's usual approach, keep projects under wraps until close to release, it's plausible that they would delay disclosure until hardware is mature. Based on analogous Tesla product timelines, one could guess an announcement in 2025, with limited production beginning in late 2025 or 2026, and full-scale rollout later. Initial markets might include North America, Europe, and parts of Asia, especially developed urban centers, where demand is high and regulation favorable. But as always, delays are possible. Resource constraints, regulatory hurdles, component supply, and certification may push timelines back. Pricing is where this speculation becomes especially bold and potentially controversial. A suggested price of $170 has surfaced in rumor circles, a figure that would be astoundingly low compared to current high-end wheelchairs, which can cost anywhere from several thousand to tens of thousands of dollars. If Tesla truly intended to democratize access, it might adopt a subscription model. The base wheelchair might be offered at low initial cost, with additional charges for advanced features, autonomy software updates, or maintenance, parallel to how Tesla offers FSD, full self-driving, as a paid software option. Further, partnerships with governments, insurers, or healthcare systems might subsidize the cost for qualified users, reducing the financial barrier even further. In sum, this speculative 2025 Tesla wheelchair would represent more than just a new mobility device. It would aim to disrupt assumptions about what assistive technology can and should do. If Tesla truly embarks on this path, it may indicate a broader ambition, a world where autonomy, AI, and inclusive design converge to extend mobility to all, independent of physical constraint. If we examine Tesla's current research footprint, there's an undeniable trajectory toward miniaturized autonomy. Over the past few years, the company has filed multiple patents related to neural networks for embedded devices, AI control for low-power hardware, and autonomous robotic movement in constrained environments. Although none of these filings explicitly mention a wheelchair, their language fits strikingly well with what a future assistive mobility product would require. For example, a U.S. patent application from Tesla in early 2025 detailed a system where an onboard processor could locally infer path trajectories using compressed neural representations. Essentially, a downsized version of Tesla's full self-driving, FSD, neural net optimized for smaller devices. It's not hard to see how such a system could power a self-driving wheelchair, capable of understanding its surroundings while maintaining low energy consumption. If such technology were repurposed for mobility assistance, the wheelchair would likely include a compact neural processing unit integrated into the base chassis. This AI core would continuously analyze video streams, depth data, and spatial cues to construct a local 3D model of the environment. The onboard neural net could handle tasks like route prediction, dynamic obstacle avoidance, user intention modeling, based on past behavior or vocal tone, and adaptive path planning. Because Tesla already designs in-house chips for Autopilot and Dojo, its AI training supercomputer, the company could easily miniaturize a derivative chip, optimized for real-time decision-making under low thermal and power constraints. Such autonomy wouldn't just mean the wheelchair can drive itself, it would make it contextually aware. Imagine the user sitting at home and saying, "Take me to the kitchen." The wheelchair wouldn't just follow a pre-programmed route. It would recognize door positions, detect furniture, anticipate narrow corners, and even wait for a pet to pass before continuing. Outdoors, it could interact with traffic lights, curb slopes, and pedestrian zones, behaving as a responsible micro-vehicle. In public buildings, it might integrate with Bluetooth or Wi-Fi beacons for navigation, much like autonomous warehouse robots. Tesla's software ecosystem already provides the foundation for these capabilities. The Tesla app, currently managing vehicles, solar panels, and Powerwall systems, could seamlessly add a new mobility section for wheelchair control. Users might monitor energy usage, schedule AI updates, or locate their wheelchair via GPS if misplaced. Remote caretakers or family members could receive health and safety alerts. For example, when the wheelchair detects a medical anomaly such as an abnormal heart rate or a prolonged period of inactivity. That monitoring feature could integrate with wearables or Tesla's own sensors embedded in the chair, forming part of a proactive health assistance network. From a materials and mechanical perspective, Tesla's access to lightweight aerospace-grade composites would allow the wheelchair to achieve both rigidity and portability. Carbon fiber panels combined with structural aluminum honeycomb could reduce total mass dramatically, while ensuring durability and resistance to corrosion. The seat itself could employ adaptive ergonomics, using pressure sensors to adjust seating support dynamically, reducing pressure points and improving circulation. Such mechanisms could be inspired by Tesla's ventilated seat technology used in its cars. with added AI logic to detect when the user shifts or requires posture adjustment. Another revolutionary aspect could be energy integration. Tesla's engineering excellence in battery design might enable a wheelchair with a solid-state lithium-ion pack offering 40 to 60 miles per charge. This is not far-fetched. Smaller EV scooters already achieve 30-40 miles of range, and Tesla's battery density far exceeds consumer mobility products. The company could even repurpose older 2170 cell formats from its vehicles to maintain cost efficiency. Fast charging compatibility, potentially through a miniaturized supercharger adapter or household wall unit, would reduce downtime drastically. A quick 15-minute charge could restore several hours of mobility. And just as with its cars, the wheelchair could employ regenerative braking, reclaiming energy when descending ramps or slowing down. One speculative but exciting possibility is bidirectional connectivity. If Tesla expands its energy vision, the wheelchair's battery might double as a portable power source, charging devices, lighting equipment, or even providing emergency backup power. In natural disasters or blackouts, this would turn the chair into a literal lifeline, especially for users relying on medical electronics. The user interface of the Tesla wheelchair could set new standards for accessibility. Instead of a joystick or traditional button panel, the interface could be entirely multimodal, combining voice control, eye tracking, facial gesture recognition, and brain-computer interface (BCI) compatibility. Given Elon Musk's ongoing Neuralink venture, it's not impossible to imagine optional BCI integration, allowing users to command movement through subtle neural signals. For users with severe mobility impairments, this could be revolutionary, navigating purely through thought or gaze without any physical effort. Even without Neuralink, Tesla could achieve significant control precision through microphone arrays and computer vision. Imagine simply looking toward a destination and saying "go," with the system interpreting both the gaze direction and the spoken command. In terms of comfort and health, the speculative Tesla wheelchair might feature an intelligent seat module that automatically shifts angles and positions throughout the day to prevent muscle fatigue and pressure sores. Integrated biometric sensors could monitor heart rate, posture, and body temperature, sending data securely to caregivers. The AI might even analyze long-term patterns, detecting subtle changes that could indicate circulatory issues or early signs of fatigue, prompting rest or repositioning suggestions. This level of holistic monitoring moves beyond mobility into wellness. Let's talk about safety, a cornerstone of Tesla's brand identity. The wheelchair's autonomous system could leverage the FSD safety stack, scaled down for human environments, to perform constant obstacle detection and emergency response. It might include an emergency stop function accessible through voice, "Stop now," a manual button, or automatic triggers if an imminent collision is detected. In shared spaces, the wheelchair could broadcast its position via low-power radio beacons to nearby smart devices, warning pedestrians or other autonomous systems of its path. Visual cues such as LED lighting strips could indicate intent: blue for standby, green for moving, red for stopping, creating a language of motion easily understood by others. In case of a fall or medical emergency, the system could detect sudden posture changes or lack of response, automatically notifying pre-designated contacts or emergency services, transmitting GPS coordinates, and streaming health data if authorized. This kind of integration reflects Tesla's larger ambition of combining transportation, data, and safety into a single ecosystem of connected intelligence. But perhaps the most transformative feature in this speculative Tesla wheelchair would be its active assist posture system, a set of electric actuators allowing the seat to gently raise the user into a standing position. This ability to stand, even temporarily, could change everything. Improved blood circulation, muscle tone, bone density, and perhaps most importantly, the social and psychological impact of meeting others at eye level. Many existing medical-grade chairs offer partial lift mechanisms, but they are slow, bulky, and lack finesse. Tesla's approach, using linear actuators optimized for smoothness and stability, could deliver an elegant, almost cinematic motion, silent, precise, and empowering. With such an integrated system, the line between vehicle and assistive device begins to blur. This wheelchair would not merely be a tool for the disabled, it would be a personal mobility platform for anyone seeking autonomous microtransportation. Students on campuses, workers in large facilities, elderly individuals in retirement communities. Anyone could benefit from a safe, self-driving, AI-powered chair. In that sense, the Tesla wheelchair might represent the democratization of robotics at the individual scale, bringing self-driving technology from highways to hallways. Of course, the speculative nature of this vision must be emphasized again. No public statements confirm Tesla's involvement, and it's entirely possible that similar technologies are being developed by other robotic startups or university labs. Yet Tesla's unmatched ability to integrate hardware, AI, and software ecosystems makes it the most likely candidate for such a revolution. The rumors, while unverified, align closely with Tesla's long-term mission: to accelerate the world's transition to sustainable energy and mobility. Expanding that mission to include personal assistive devices feels like the next logical, humane step. If Tesla were to unveil such a product, the implications would ripple far beyond the disability technology market. It would mark the first time that a mainstream consumer brand associated with futuristic innovation made accessibility a frontline narrative. Historically, mobility devices have existed in a medicalized niche, necessary, functional, but rarely aspirational. A Tesla entry would change that psychology entirely. The same way Tesla rebranded electric cars from niche eco-gadgets into luxury performance icons, this wheelchair could rebrand assistive devices as symbols of empowerment and independence, not limitation. The global wheelchair market in 2025 is projected to exceed $10 billion annually, driven by aging populations and improved healthcare access. Yet innovation within that sector lags dramatically compared to consumer electronics. By bringing AI, design, and affordability into play, Tesla could create a halo effect, pushing competitors to follow suit, accelerating innovation across the entire accessibility ecosystem. For users, that means more choice, better design, and reduced cost barriers. For the tech industry, it might catalyze a new class of personal robotic mobility platforms, bridging healthcare, transportation, and consumer robotics in one device. The most transformative dimension, however, would be social inclusion. For decades, wheelchair users have had to adapt to environments not built for them: curbs too high, aisles too narrow, transportation systems too rigid. The Tesla wheelchair flips that dynamic. Instead of the user adapting to the world adapts to the chair. With advanced mapping, AI navigation, and wireless integration, the chair could negotiate modern infrastructure with the same intelligence that Tesla cars use on highways. Doors could open automatically when the chair approaches, elevators could sync, and buildings could integrate movement data for smoother access flow. This is not just convenience, it's dignity, designed into technology. Then there's the psychological effect of autonomy. For individuals who've relied on caregivers for mobility, gaining a device that independently navigates space means a restored sense of agency. The act of choosing when and where to move, without waiting for assistance, carries immense emotional weight. It's not about replacing caregivers, but about rediscovering personal freedom. Many users describe that autonomy as a form of identity restoration, a quiet revolution that redefines what independence means. Let's revisit one of the most striking rumors attached to the speculative Tesla wheelchair, the $179 price point. If such pricing ever materialized, it would represent a nearly utopian level of accessibility. To put it in perspective, most power wheelchairs cost between $5,000 and $50,000 depending on customization. Even a stripped-down mobility scooter can cost over $1,000. So how could something that's allegedly AI-powered, battery-driven, and sensor-equipped come in at $179? The only feasible model would involve Tesla adopting a hardware-as-a-service approach, where the upfront cost covers the physical chair, and advanced features are unlocked via subscription. Users could pay monthly for navigation intelligence, health monitoring, or cloud-based updates. It's similar to how Tesla's FSD software operates today. The hardware exists in all vehicles, but the autonomy features are paywalled behind software activation. Beyond business models, This speculative pricing also plays into Elon Musk's broader philosophy of abundance through scale. By manufacturing at volume, Tesla could reduce costs dramatically, leveraging the same gigafactories that produce EV battery packs and motors. Economies of scale would make what was once a medical luxury into a consumer commodity. And by coupling that affordability with sleek futuristic design, Tesla would shatter the stigma surrounding assistive devices. In short, you wouldn't just use it because you need it. You'd want it because it's brilliant. But every innovation comes with challenges. If Tesla truly ventured into medical or assistive mobility, it would face an entirely new regulatory landscape. Wheelchairs are classified as medical devices under FDA and EU MDR frameworks. That means compliance with strict safety, testing, and certification protocols. Tesla's experience in automotive regulation, particularly in safety-critical systems, gives it an advantage, but adapting those standards to human-assistive contexts would require partnerships with healthcare institutions, and perhaps even the development of a new Tesla Health Mobility division. The chair's ability to monitor vitals and integrate health data raises important questions about privacy, medical liability, and ethical data usage. Would Tesla's AI analyze user biometrics locally or transmit them to the cloud? Would users retain full control of their data? For such a device to gain trust, transparency would be essential. If the company succeeds, the benefits could be monumental. Consider an elderly user in Tokyo navigating dense streets without fear of collision, or a young athlete with spinal injury commuting independently to class, or a war veteran exploring hiking trails previously inaccessible. In every case, the Tesla wheelchair's intelligence would expand not just physical movement, but the boundaries of life itself. It could enable travel, employment, recreation, and participation in public life, all areas where mobility challenges have long imposed invisible walls. On a technical level, the synergy between Tesla's broader ecosystem and the chair's autonomy could yield remarkable convenience. Imagine the chair communicating directly with a Tesla car. As the user approaches, the vehicle lowers its suspension, opens the door, and deploys a small ramp. The wheelchair locks into a docking bay inside the car, automatically beginning to charge during travel. Upon arrival, it detaches and continues seamlessly. This would effectively close the loop of door-to-door autonomous mobility. It's a vision that blends robotics, electric transport, and user experience into one fluid continuum. From a cultural perspective, this project, if real, would represent a moral evolution of technology. For years, critics have accused Silicon Valley of focusing on convenience for the privileged, faster apps, more streaming, smarter gadgets. The Tesla wheelchair would invert that narrative. It would place innovation at the service of those who most need empowerment, not just entertainment. It would embody the idea that the future isn't only for those who can afford it. It's for those who have been waiting for it the longest. In that sense, this hypothetical product is less about Tesla itself and more about the symbolic direction it points to. A world where machines don't just assist us, they understand us, where AI is not a threat to humanity, but a prosthesis for it. By extending intelligence into mobility aids, humanity moves one step closer to a truly inclusive technological civilization. Of course, there remains the central question: is it real? At the time of writing, October 8, 2025, there is still no formal confirmation from Tesla. The company has neither teased a prototype nor acknowledged development. Yet whispers persist. Patents hint at compatible AI architectures. Social media leaks from Tesla-affiliated engineers show concept sketches, and speculative videos keep fueling public imagination. Whether coincidence or coordinated misdirection, the rumors persist because they feel possible. Tesla has always specialized in turning impossibility into inevitability. First with electric cars, then rockets, now perhaps mobility itself. And so, the story ends not with certainty, but with invitation. The 2025 Tesla wheelchair may remain a myth today, but myths have a way of seeding reality. If you believe in this vision, if you think technology should serve inclusion, empowerment, and human dignity, then stay tuned. Subscribe, follow the updates, and keep the conversation alive. Because sometimes the future doesn't begin in a lab or a boardroom. Sometimes it begins in a rumor, in a sketch, in an idea shared between dreamers who refuse to accept the limits of what's possible.